friends, so today we are solving this problem, reschedule meetings for the maximum free time. So we are given an integer event time, which denotes basically that starting from 0 up to this event time we have the meetings that happens. So we are also given an integer array start time and end time, and each of length n, both of them having same length. You can visualize like this, so you can understand here. This is, we are given an array of the start and end time for the meetings. For example, these are the meetings m0, m1, m2. Then see here, it's starting, m0 is starting at 0. You can see here it is starting at 0 and ending at 3. Similarly, m2, the meeting 2 is starting at 4 and ending at 5. So see here, in the second array is the end time, and the first array is for starting time for ith event. Similarly, you can see the third one is starting at 6 and ending at 7. You can visualize here. So this is what given, and we are also given the event time. So you can see here, starting from very first the 0 and event time, the last one is the 7. So this is like total plot of the time interval that we are taking place. Okay, and we are also given one k, integer k, which indicates that out of these meetings, the k meetings we can do rescheduling. So what basically we have to do is, after doing the k rescheduling out of any meetings, the k rescheduling of the meetings are allowed. Then what we have to do, we have to find a way so that if we reschedule the k meetings, we have to have the maximum free time in the sequence. It should not be gap. Like in this case, you can see here that 3 to 4, there is a 1 hour gap here. Similarly, 5 to 6, there is a 1 hour gap. But this gap is not consecutive, right? There is a one meeting between them. So we have to reschedule the meeting in such a way so that we will have the consecutive free time. Instead of in gaps, we should have 2 hours consecutively. So what we can do here is, for example, here k equal to 2. So if what I do, if this 4 to 5, if m1 meeting, if I schedule it to 3 to 4, this is 1 hour, right? So I can schedule it like this. Let me schedule it like this. So I can do it for 3 to 4, correct? So if I do 3 to 4 rescheduling of this meeting, and then one more rescheduling of the m2 also, this is also 6 to 7, but we can make it from 4 to 5. So let's say if I do this meeting also for 4 to 5, both of them are rescheduled. So up to k, so we have k equal to 2. So 2 meetings if I reschedule, now 5 to 6 and 6 to 7, these hours are consecutively available now. But initially it was available in the parts, like one hour, then one meeting, then another 1 hour. So this is what we have to do. So we have to find the after doing the k rescheduling, how to get the maximum consecutive hours which are free. This is what we have to do. Now next thing is how to do it. Okay, so we have to take care that k is the whatever value, that many meetings we have to reschedule. So this is what we have to do. So let's get an intuition that how to do that. So I have another example. This is one simplest example where we got these 2 consecutive values. So answer for it should be 2, right? Because we got the 2 free space, 2 hour free space in a better way, if you want to say. So we got 2 free space. Now let's say we have a better example, not only this. Suppose we have this kind of meeting rescheduling where k equal to 3 this time, and event time is ending at 16, starting from 0, right? So and now one more thing is, a meeting need not to start from very first, right? It need not to start from 0. It can start in first also, or 4th hour, or whatever it is. But it should end, the last meeting should end at the event time, whatever is given in the question. Now here what would be our approach? How to get this intuition first of all? So instead of going directly to the solution, let's build some intuition here. So you guys know that, let's say if we want to reschedule these 2 meetings, what will happen if we bring them together? So there is a space, right? If we reschedule these meetings, there is a plot like this from 0 till 7. If I draw a boundary here, you can see that these 3 space we have, this one, and this one, only for these 2 meetings, right? So if I bring them together here, then these 3 space should be free for me. just because of these two rescheduling, right? So this approach, what is happening here is, if we look at the plot of these two events here, so it is starting at 0 and ending at 7, right? So this would be like 7 minus 0, so 7 hours is the plot here. So out of these 7 hours, how many are being consumed by the meetings? You can see here 2 hours here and 3 hours here. So we got this 7 hours. So if 7 minus 2 here and 1 here, so 3. So 7 minus 3 if we do, we will have 4 hours as the free space consecutively, right? So this would be our intuition here. So how do we do that? Now here we have done only 2 meetings, but in the question it is given up to k meetings we can reschedule. So what we can do is, these 3 meetings has to happen consecutively, or whatever k number, it has to happen consecutively, because if they are not consecutively, there would be a gap, right? If I let's say if I reschedule this meeting and this meeting, right, then I cannot get the consecutive free space, because these meetings are in between them, which will divide again the time. So that is why from here we are getting the intuition that our meeting that we gonna reschedule should be consecutive. Okay, k consecutive, otherwise we will not get the best result, because then we are finding another gap if we pick the meetings like this with having the other meetings in between, right? So one intuition we have got, that we have to reschedule all those k meetings, which are the consecutive. Now if they are consecutive, then we can have an intuition that consecutive things brings us in our mind the sliding window, right? Sliding window is consecutive values only. So in this case, what will happen? Now it is giving us the intuition of the sliding window. So first we will take these 3, right? Then we will take next set of 3. Then we will exclude that also. We will look for the next set of 3, and we'll see that which one makes the biggest free space, and that would be our answer. So this is our intuition. Now we will do the exact dry run for each and every things, that how to do that. Okay, so let me do that. You guys can observe here that I have created these 3-4 variables. So this time would be definitely for whatever number of hours, the time taken by the meeting itself. So this would be parked in this variable time, and this left and right are the variables which are the like for a given meeting M1, or the left one is the from where our plot is being start for the current window. Like in this case, this 0 would be the left side for this M1, and this 4 would be the right side for this M1. So in case, now you can observe here that if this M1 is not the last one, in that case whoever is the next meeting, its start time would be basically the right time for it, and the left would be the whatever is the previous. Okay, so in that way we have to calculate the value. So we will calculate the whatever would be the plot, like for the meeting 1, 4 is the right side and 0 is the left side, and the time would be 3 minus 1, because it is ending at 3 and started at 1. So 3 minus 1, so this would be 2, time would be 2 here, left would be 0 and right would be 4, right? So let's do the dry run of this example. Here k equal to 3, so time initially it was 0, right? So what we will do is, we are coming to this meeting M1, right? So M1 has start end time 3 and the start time is 1. So what would be the time here? Time taken by meeting by 1 is 3 minus 1, right? So this would become 2. So we have current value for the meeting 1 is 2, and what is the left side of it? Left side is the 0. 0 means the one from where we have started, because this is very first window. Okay, so this is very first of k size window. At that time it would be 0, so we are taking here 0. And what is the right here? Right would be the whatever is the next meeting, its start time. So next meeting is M2 and its start time is 4. So right would be 4 here, right? So now this max would be what? This max would be whatever is the maximum value. Initially it was 0. So we will take the whatever the maximum of this 0. Let's say 0 is the maximum current value. And what would be the free time here? So right minus left, so which would be 4 minus 0, right? This would be our right minus left minus whatever time taken by this meeting, right? So you can consider here the time taken would be, let's say I'm calling it time taken TT. So time taken by the meeting would be it would be the end minus start, right? So this would be E minus S, let's say E end minus start. So 3 minus 1, 3 minus 1, which is 2. So this 2 we have already assigned to this guy, right? Now we have this gap, right? What is the gap here? The total gap, regardless of meeting in between or not. So gap would be right minus left, R minus L, let's say I'm saying. So it would be 4 minus 0. So this would be 4 here. Now what will happen? This is 3 minus 1 equal to 2. So now we can observe that what could be the free space here if we reschedule this meeting to left side. So this would be whatever gap we have got, 4 minus whatever time is taken by this meeting. So 4 minus 2. So this would be 2. Now initially this max value has the 0. So 0 and 2. So what is the maximum between 0 and 2? The maximum would be 2 only, right? So we are done for the meeting 1 and our current window size is 1 now. Now we are coming to meeting 2, right? So we are coming to meeting 2. So at meeting 2, what would be the time here? So time would be 6 minus 4. So 6 minus 4, it is 2, and 2 is already there this time for this meeting. So 2 plus 2, it would become 4, right? Now what would be the left? Left would be still 0 because we are still inside the first window. See here, this is our very first window for size k equal to 3. This is our very first window, so we are still inside it. So for very first window, our left would be still 0. Now we are coming to this M2. So left is still 0. What is the right? Right would be M3 start time, which is 7. M3 start time is 7. So let me make that 7. Okay. Now what would be these this timing? So 7 minus 0, right? This would be our 7, right? So 7 minus 0. 7 minus 0. So right minus left. This same R minus L we did now. So 7 minus 0 would be 7. So we will make gap is 7, and what is the timing now? It is timing is 4. So 7 minus 4. 7 minus 4 is 3, right? We got this value 3. So what is the max here? 2 and 3. What is the max? So max would be 3 now. So we are done till this meeting. Now we are coming to M3. We are still in the first window. So left would be still 0, right? And what would be the right now? Right would be the maximum start time of the M4, right? So which is 10. So we will make this 10. So what would be the gap here? 10 minus 0. So it would be 10. And what is the total timing now? So this is third meeting. So 9 minus 7. So 2. So 4 plus 2, it would become 6. So 6 is so far the total meeting time. So this is the plot here. So 10 minus total meeting time is 6. So 10 minus 6. So what value got? We got 4. So what is the max here? This is 3 and this is 4. So max would be, new value would be 4, right? Now we are coming to this M4. So this is the first time when we are coming out of the very first window, right? Because now we are coming to I equal to, let's say if we starting from 0, we are at I equal to 3. Okay, and our window size is basically becoming 4 now, right? So at that time what we will do is we have to exclude this meeting here, right? We have to exclude this meeting. So what was the total time used by this meeting? This was 3 minus 1, which is 2. So basically what we have to do is we have to deduct this value from this time, because this is anyway now already used. So let me remove these extra stuff now, because this is of no use. So see here, once we are excluding this meeting out of this window, this total meeting time is would become 6 minus 2, whatever was the time. So 6 minus 2, this is 4, and now this is included here. So 12 minus 10. So this is also 2. So 4 plus 2, this would be the new value, which is again 6 anyway. So the total meeting time here again became 6. But what is the plot now? The plot would be, where is the end time here? End time here would be the start time of the M1, the one which we excluded, right? So now this time our start time would be first time becoming 3, because we are coming out of the very first window. So now left would become 3, and what would be the right? Right would be here 14, right? So right would be here, this would be 14. Okay, so what would be the total plot distance? It would be 14 minus 3. So 14 minus 3 is 11. So we have got 11 here. And what is the total meeting time here? This is 6. So 11 minus 6. 11 minus 6 equal to 5. Right? So what is the max here? This is 4 and this is 5. So we got the max again F5. Correct? Now we have to further go ahead. So what to do next? We will go to M5 finally. So if we are coming at M5 here, this is our last one. So in that case, we have to exclude this meeting because our window should be still of 3 length, right? So we will exclude this meeting. So what was the time taken by this meeting? The time taken by this M2 was 6 minus 4. So that was 2. So we have to deduct this 2. So 6 minus 2, it would become 4. 4 plus whatever is the timing of this meeting. So 16 minus 14. So this would also 2. So 6 plus 2. Again it becomes 6, right? So it became 6. Now what would be the left here? Because this is excluded this time. So left would be whatever was the start time of the one which is excluded. So now this time start time would become 6. So let me make it 6 here. Okay. Now what would be the end time? Because we are at the very last meeting. So if we are at the very last meeting, the end time would be whatever is the event time given in the question. So this would be 16. So now here end time would be 16. So what will be the difference? Difference would be 16 minus 6. So what 16 minus 6 would be 10, right? So this is 16, this is 6. So 16 minus 6, this is becoming 10. And what is the total event time now? So this is again 6, right? So 10 minus 6, what it would be? It would be 4. So if it would be 4, we will check which one is maximum. So this is 4 and this is 5. So maximum is 5 itself. So we will not make any change. So now we can say that 5 would be our answer, right? So we are doing in the sliding window paradigm here, and we are not using any extra space if we go in this way. So let me show you my corresponding code, and we are doing in O of n time complexity. So let me show you corresponding code here. So you can see here, first of all, what I am doing, all those 3 variables, 4 variables, right? Right, time, left, and this 3 time. That should be our answer. And see here, I am getting the length of start time because start time and end time both are of the same length. Okay. Now what we are doing here is we are traversing through this windows, right? Through this array. So I equal to 0, I less than I plus plus. What I am doing here first of all is time equal to whatever is the end time of the meeting minus start time of the meeting. So here this time would be taking the values just like we were calculating here this time, right? For every meeting, end time minus start time. So that we are doing here. Then we are checking here. You can see left equal to, we were checking here every time this left, right? So you are checking here. What we are doing is if this is very first window, you can check here. If this is very first window means if I is still less than or equal to k minus 1. Why k minus 1? Because I is starting from 0. So if we are index 2, that means it is of size k equal to 3. That is why we are making it. So if it is in the very first window, because we haven't reached, in that case we are taking left equal to 0. You can see here till this time here we were taking the left equal to 0. This, see here, it was 0, it was 0, it was 0, right? So we are making same condition. If it is in the still in the very first window, a sliding window, then we are taking 0. Otherwise we are taking end time of I minus k. Why I minus k? Because you can see here when we excluded this window, when we were coming to this window, you can see here, you can visualize when we excluded this, our new window was like this, right? So our new window was like this. In that case, what happens? Our start plot time, this left became here. Whatever was the end time of the one which we just left, and this end time would be our I minus k, right? If we are at this I, then I minus k will give us this guy end time. So that is why we are taking here. Otherwise, it would be end time of I minus k. Similarly, for the right also, if I equal to n minus 1 means if we are at the last one, just like we are here, when we reached here, At this point, what we did is, when we were at the last point, I was n minus 1. In that case, we took this event time. Otherwise, if we are in between, then we are taking the start time of whoever is the next guy. So I plus 1 start time, right? So we are doing, that is why, that if it is last one, if I equal to n minus 1, then we are taking event time. Otherwise, we are taking the start time of whoever on the right side. Just like if we want to get the start time of this, we will get the end time of next guy. Means if we are at ith place, then I plus 1th start time would be our thing. So that is why we are taking here like that. So we populated time, we populated left and right. Now this is the just the boundary length, that plot I was saying. So I just got this right minus left. So now this free time would be my max where I want to park the value. So we are taking that whatever is the math.max of free time and whatever is the boundary length minus whatever the time taken by these meetings, just like we were doing here. Every time we are doing right minus left minus whatever the time. So same thing I'm doing here, and we are checking at this place that if I is greater than or equal to k minus 1, means whenever we are reaching to the windows size, right? If I is becoming k minus 1 or greater, then what we are doing, we have to exclude the meeting time of the very first added meeting. Just like when we reached here, right? When we reached here, then we have to exclude this one because k is equal to 3, right? So if we, let's say we included all of them, then we have to remove this very first guy because we have to keep the window size 3 only. So for that reason, what I am doing here is I am updating that if I is greater than or equal to k minus 1, at that time we are updating this time equal to whatever was the very first value, right? So we are taking I minus k plus 1. This will give us the very first value of the current window. Okay, so at that time we are deducting the meeting time of it. So see here, that is why we are doing end time of this first one minus start time of it. We are deducting it from the time, so that we have the total time excluded for the very first, the one which is gonna excludes from the current window. Okay, so in this way, when we will come out of it, we will have this free time value have the maximum value. So we are not using any extra space other than these few variables. So and in single traversal we are doing. So let me execute this code, which I have already done, but let me do it again. See here. So I am submitting it. Yes. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.